Types of vectors we are going to discuss about we are already discussed about the several types of vectors, that is unit vector and as well as equal vectors and axial vector, like that. Now we are going to discuss about position vector. What is meant by the position? With respect to the one point, if we said that another point's position, that is called as a position vector. If in case of a, consider P is a particle in the coordinate system x, y, z are the coordinate system, in the direction of x, y axis I, j, k are the unit vectors. Already we know that. So the unit vector is used to specify that, means the vector used to specify the position of a particle, where that position is of a particle with respect to the fixed position, fixed point, with respect to the fixed point. If in case of the position of a particle is explained with respect to the another fixed point, then the position can be considered as, that is the according to the coordinate system, that is the position vector according to the coordinate system, means the position is explained with respect to x, y, z axis with respectively. So here is that is consider this is the coordinate system and P is the point. We are going to know the position of the point P with respect to x, y, z. According to the x, y, z, the position of a particle is with respect to this. This will be the x, parallel x, because of this x axis, y axis and z axis. Along this one, this is the x axis, this is parallel to x axis, so that's why we can say that this is according to the x axis the position of a particle, according to the y axis, and as well as we can modify that one, this one is the according to the z axis, means this will be can be considered as according to the z axis, means according to this one, means this one. According to this one, this will be the z axis and this is according to x axis, and this position can be considered, this is according to y axis. This will be the position according to this. The position vector can be considered as, it can be denoted with r bar, and as well as if in case of the coordinate system, according to the coordinate system, the position of a particle P can be obtained as can be expressed as OP is equal to x I bar I cap plus y j cap plus z k cap. Because of here I, j, k are the unit vectors along the, I is the unit vector along the x axis and y, j is the unit vector along the y axis and k be the unit vector along the z axis. So that's why we can be considered as here x, y, z are the magnitudes of that one. We know that if in case of we are finding the magnitude of any vector, means the length of the vector we are obtaining. We are knowing, we are measuring that the length of the vector, the magnitude of the vector means the length of the vector we are measuring. So here is that this is the x, y, z are the lengths of the magnitude, means magnitude of the vector means the length of that vector. So that's why here OP is equal to xi plus yj plus zk are the, we can obtain by using the, it can be expressed as r bar is equal to, means OP means that is a position vector, r bar is expressed as a position vector. So that's why OP bar is equal to r bar is equal to xi plus yj plus zk. Here the vectors can be considered as by showing the arrow on the vector, that is r, like this. Otherwise in textbooks we can be seen like in bold letters, that can be expressed. So that's why here this is the position vector. The distance of P from the origin we can be calculated by the using the unit vector, means the magnitude of P. We know that the magnitude of P means we have the equation for the r bar, the length, the total length of the r bar is equal to xi plus yj plus zk is the equation in terms of we can be expressed. So that the magnitude of r bar is equal to any vector, that can be any vector we can measure by the length. Magnitude means we are measuring the length of that vector. Here is that the length of the r bar means magnitude of r bar means modulus of r bar, that is equal to square root of x square plus y square plus z square, means if in case of can be considered r bar is equal to, if we get that 2i plus 3j plus 4k, then to find out the magnitude of this vector, then mod r bar is equal to under root of, we can be calculated 2 square plus 3 square plus 4 square be the equation. Now by calculating this equation we can find it out the length of the position vector, means the vector magnitude of that vector, and as well as the unit vector along the r, means here is the r, along the r the unit vector along the r will be r cap is equal to, we know that, means what is unit vector, how to find out the unit vector r cap, that can be denoted as r cap. R cap means the division of the magnitude of that vector. A vector with dividing with the magnitude of that vector is can be calculated as a unit vector. So that's why r bar by mod r bar, r bar is the unit vector, we have taken that by dividing the magnitude of that vector, means modulus r bar by modulus of r bar is equal to, we know that r bar means the equation is xi plus yj plus zk is the equation for the position vector, then that is xi plus yj plus zk by root of x square plus y square plus z square be the equation for the, to know the magnitude or to know the unit vector of a position vector r bar. Here once again the position vector means to specify a vector to specify, use it to specify the position of a particle with a point with respect to the fixed point, like origin, say origin, to know the vector used to specify the position of a point with respect to the fixed point, say origin, is called a position vector. Here we are considering that P is the vector that can be, to know the position vector, then we can according to the coordinate system we can verify that, we can express that position of that P. So that is OP be the here position vector, that can be expressed as r bar is equal to OP bar is equal to xi plus yj plus zk. Then here xi cap, y cap, j cap, j cap, k cap is the unit vectors with respect along the direction of x, y and z axis. So that's why here the distance of P from origin is, means distance of P from origin be the magnitude of r. So the magnitude of r is equal to, we know that the modulus of r bar, the modulus of r bar is the magnitude of P, means to know the length of that vector. So here it is to know the length of that vector, that is root of x square plus y square plus z square, means whatever the factors are having that by the equation, in case of in position of x, y, z, instead of x, y, z there is some numbers also, their values if given. To know this we can write that mod r bar is equal to root of 2 square plus 3 square plus 4 square, if in case of the equation is 2i plus 3j plus z 4k bar. Then from that equation we can verify we can find out the magnitude of the vector, or we can say that length of the vector. So to know the unit vector of r bar along the r bar is r cap. R cap means the unit vector of r. The unit vector of r means, what is unit vector? How to find out the unit vector? The vector is divided with its modulus or with its magnitude of that vector. A vector is divided with that modulus magnitude of that vector, or modulus of that vector is can be calculated as the unit vector. So here it is that r cap is equal to r bar by mod r bar is equal to xi plus yj plus zk by root of x square plus y square plus z square. These are the most important thing in types of vectors. Already we discussed about that, the unit vector, null vector means zero vector, parallel vector, equal vector and several etc. Then these are the most important types of vectors, several types of also there. Then now after knowing the types of vectors, if any two vectors are added, any two vectors are added, that vectors are added in several types also. If in case of the vectors are moving to in same direction, means addition of vectors. Here the addition of vectors means, if in case of the vectors are moving in the same direction, two vectors are traveling in a same direction, that can be added when the resultant direction can be in the direction of the large magnitude vector. We should remember that one. The resultant direction of that vector, after adding the resultant direction of the vector is the resultant direction of the vector is in the direction of the large magnitude vector, in the direction of the large magnitude vector. This is the A bar is having the large magnitude, means large lengthwise is more, and this is the B bar lengthwise is less, means magnitude is less. So whenever we added then A bar with a B bar, then this is C bar is equal to A bar plus B bar. Here C bar is the resultant vector. Resultant vector in the direction of the large vector, in the direction of the large magnitude vector. So that is the, when addition of two vectors moving in the same direction, we can calculate that the C bar is equal to A bar plus B bar, like this. If in case of one vector is moving one direction and another vector is moving opposite direction to that vector, then what will happen? Here we told you we already know this, the direction of that vector is in the direction of the large magnitude vector. So that's why here A is having the more magnitude and B is having the, which is in opposite direction to the A, that is a less magnitude. So the resultant will be in this direction A bar plus of minus B bar, because of large magnitude is in this direction. So that's why the resultant vector is also in this direction. So that's why the direction of resultant is same as that of a larger vector in magnitude, larger vector in a magnitude, in magnitude. So here it is that A bar minus B bar, A bar minus B bar. If in case of, if the vectors are moving in the same direction and moving in the opposite direction, either, if in case of mutually inclined, if two vectors are mutually inclined like this, if in case of A bar is moving in this direction and B bar is in inclinedly, then the resultant vector is like this. This is the A bar already in the direction and B bar is in the direction. Then the resultant will be opposite direction to the, always remember the resultant vector is in opposite direction to the direction of vectors, means if in case of this both are in anti-clockwise, then the resultant vector is in a clockwise direction, means whenever the direction will be moving in this direction, then the resultant will be in the direction according to the triangle of vectors. Next we will discuss about the triangle of vectors. So C bar is equal to A bar plus B bar is the resultant vectors. So these are the about the addition of vectors. Then in this vectors, some of the vectors will obey in addition of vectors. This is the in addition of vectors. What are the laws obeyed by these vectors? The laws of addition of vectors, means laws of vector addition, we can be say that laws of vector addition. Laws of vector addition means there is a three types of laws of vector addition is there. Those are the commutative law, associative law and distributive law. These are the three types of laws of vector. After knowing this addition of vectors, means whenever the vectors are moving in the same direction or vectors are moving opposite to one another, means in opposite direction, and whenever they are mutually inclined, then what is the laws obeyed by that vectors? So here is the three laws are obeyed by the addition of vectors. Already we know that the definition of vector means whose the physical quantities are having magnitude and direction, and they must obey the laws of vector addition. Laws of vector addition, then only that can be say the quantity, physical quantity can say as a vector. Here is, these are the three laws of vector addition. The first one is a commutative law. In this case of commutative law, here the two vectors are there. Two vectors are there, that is considered A bar and B bar. Whenever they are added in any manner means either A plus B bar, the sum of the two vectors is independent of, the sum of the two vectors is independent of in the order of the vectors. If in case of the order may be the different, means A bar plus B bar, either if the order is changed for B bar plus A bar, like 1 plus 2, that is equal to 2 plus 1 is also same. Like that, here A bar plus B bar is equal to B bar plus A bar. If in case of any vectors obeyed this law, then that can be considered as a laws, that is a vector. The next one is a associative law. Associate means to combine. in whatever the order is there to combine the three vectors, then we can get the resultant will be same. Like that, if in case of here, first here commutative law means A bar direction moving in this direction, B bar will be same. Then this will be the resultant, that is A bar plus B bar. Either A bar is moving in this direction, B bar is moving in this direction parallel to this one. If the resultant is on opposite direction, then B bar plus A bar is also same. Both are the resultant having the same line. So that can be said that is obeys the commutative law. If any two vectors obeys that one, that is called as vectors. Then associative law means A bar is moving in this direction and B bar is moving in this direction, and the third vector C bar is moving in this direction. By adding this in any manner, in any order means either A bar, B bar, C bar. By adding this one, if in case of the resultant will be A bar plus B bar, we combine this A bar and B bar, A bar plus B bar. Then the final resultant from A bar to C bar will be A bar plus B bar plus C bar. Means this one is the C bar. So A bar plus B bar plus C bar means A bar plus B bar plus C bar. The same resultant we can get that A bar plus B bar plus C bar. Here this is the line, as well as which is equal to then the same line, the resultant line will be the same. And whenever the A bar and B bar and C bar, this is the B bar plus C bar line, this is the B bar plus C bar one. Then if we add it to A bar, then A bar plus B bar plus C bar, the same resultant line, that is P, Q, R, S, the same in opposite direction, the same line means the same resultant we can get. Means here when adding more than two vectors, one can group them and any order to find the resultant, one can group them means like here A bar plus B bar plus C bar, one can group then any order, in any order to find the resultant. The result is independent of the order means A bar plus of B bar plus C bar, like this. Means the result is independent of order. In any manner if we add it, the sum of this, the result will be is independent of the order in which they are grouped. In any manner if we group that one, then we can get the same result. If the vectors obeys this one, A bar plus B bar plus C bar, that is equal to A bar plus of B bar plus C bar, then that vectors will obey the laws of vector addition in associative law. The next one is distributive law. In this distributive law, if in case of the consider K1, K2, K3 are the scalars, then here K of A plus B are the vectors. So if we multiply this one in the direction, then Ka plus Kb, we will get the same result. And as well as here A bar of K1 plus K2, then is also we can find out that K1 A bar plus K2 B bar is also, we can get the same result. So here is that the above equations can be shown that the vectors obeys the distributive law. These are the three types of laws which can be obeyed by the physical quantities. Then it can be said as a vectors, means commutative law, associative law and distributive law. The three laws are laws of vector addition.